Welcome back. We've talked about the theory, but how do we use the cluster module? How can we apply clustering to our Node servers to improve performance? Let's go back to our performance example code and create two forks of our server which can each handle requests concurrently, side by side. First things first, to use the cluster module, we need to require our built-in cluster module, assigning it to a constant that we'll call cluster. Now we make our cluster of processes. Remember our diagram. When we type node server.js, what we call the master process is started. And it's from this master process that we can call our fork function to create these two worker processes. The worker processes that we fork run the same code that we have in server.js. The only way we differentiate our master process from the worker processes is by using the isMaster Boolean flag from the cluster module. So down here, right above our app.listen call, we can write if cluster.isMaster, and any code inside of this block will only get executed the first time that our server.js file is executed as the master. Let's log that to our console so that we can see the master has been started. And anything that we write in the else condition here is when isMaster is false and our code is running as a worker process. So we'll say console.log worker process started. What we're going to do is fork two workers which will run the Express server with the two routes that we've defined here. So from the top, we run node server.js, we're the master, and now we want to call cluster.fork. Each time we call this function from the cluster module, we create a worker. We can do this however many times we'd like, but let's just start with 2 for now, just like that. Perfect. What about the workers? It's only as a worker that we want to listen for incoming HTTP requests and handle them using our Express routes. So we'll only call app.listen when we're running as a worker process. When we start an HTTP server in one of our worker processes, whether it's Node's built-in bare-bones HTTP server, or whether it's something like Express, Node's cluster module understands the listen function. Node knows that each of our workers will be listening on the same port, on port 3000. And the Node HTTP server knows to divide incoming requests that are coming in on port 3000 between the different worker processes. For each request, in our request handlers here, let's use our template string to send not just the performance example text, but also we can use the built-in process module, the process module with our argv array, which we used to get the command line arguments to our Node programs. The built-in process module also has this process.pid property to get the ID of the current process from the operating system. This is useful to us because our master thread, as well as all of our worker threads, will have different PIDs to help us see that different processes are indeed actually handling different requests, that our processes are sharing the load. So we'll say process or performance example is running on this process, and our timer was run on process.pid. Now we'll know if our different requests are being handled on the same process or a different one. Let's run our tiny little cluster of 2 workers. We can start our master process by running node server.js or by typing npm start. They're equivalent. Beautiful! Our master has been started and 2 workers were created immediately afterwards to listen for incoming requests. Before we play around with our server to see how much it helps our clustering, helps our server to respond quickly, I want to reinforce just one important concept, which is that every time we call fork, when we're in the worker process and when we're in the master process, we're always running server.js. The code for each process is the same. The only difference is this isMaster flag. To demonstrate this, we can console.log right before our conditional to say running server.js. Now, what do we expect to see if we run npm start? Let's take a look. I'll Control-C out of our process here. This will terminate the worker processes as well. I'll also clear the terminal and run npm start. You can see that for the initial master process, as well as the 2 workers, our server.js code was executed. The first time, as the master, forking our 2 worker processes, and then the second time, as the worker, listening for incoming connections. Let's open up Chrome and test our cluster. In one tab, we're going to try to navigate to the timer endpoint. And in the other tab, the root, which should respond much quicker. Remember, when we had just one node process, the blocking timer request prevented our quicker root route from responding until it was finished. And trying to navigate to the timer endpoint in 2 different tabs resulted in one of those requests taking more than twice as long. So I'll open up the Chrome Network tab in our JavaScript console, first in one tab, and then in the other tab as well. Now watch out. Here's where we have to be careful. Chrome, and some other browsers as well, try to be clever. And if they notice you making 2 identical requests, for example, to the timer endpoint in 2 tabs in your browser, when Chrome detects that you make the same request at nearly the same time, it waits for the first request to complete before it even tries to make the second request, so that it can potentially reuse the response if the response is saved to your browser's cache. This is a little-known feature that can cause confusion if you're not aware of it. Chrome is trying to minimize the amount of traffic on your network. But this isn't great when testing our server's performance. So when testing our server clustering, what we need to do is disable the cache so that Chrome actually makes our requests side by side at the same time. So I'll make sure to select Disable Cache in both tabs. Or we could press the key combination to refresh without the cache. For example, Control-Shift and R, or Command-Shift and R in Chrome if you happen to be on a Mac. We're finally ready. Let's make our 2 requests in one tab to our timer endpoint, and really quickly I'll switch to the second tab and refresh there as well. First and second, we can see in the first tab, the connection is pending. I'm going to wait 9 seconds, and here we go. 200 response. And at the exact same time, I got back the response in the other tab. Both requests took 9 seconds. They were run in parallel on my computer because I have 2 CPU cores, and they were handled in 2 separate processes. We can see that we logged the process ID. For this request, it was 24730, and on this one, we have a different process ID. I could make a request to the timer endpoint in one tab, and in the other, go to the root, and the root request came back almost instantly, after 20 milliseconds. I now have a few less applications running on my machine, so the requests are coming back a little bit faster. But the difference is drastic. Our root endpoint here didn't have to wait for the timer in the first tab to complete. This is exactly what we want. We've solved our performance issues. Or have we? In the next video, let's discuss how to best use clustering in the real world. I'll see you soon.